Okay, so we have seen about what is the molecular mass, what is the formula mass, the mole, what is mole, what is Avogadro's number. Let's see how we calculate a few numericals. We see a few numericals, how to solve them, and then we go ahead with the next part. So the first numerical, calculate the mass of the following. The first one atom of sodium. How to calculate the mass of one atom of sodium? Now we know 1 gram atomic mass of sodium is 23 grams. So number of atoms present in 23 grams, because it's the atomic mass. So number of atoms present would be 1 mole. And what is 1 mole? 6.022 into 10 to the power 23 is 23. Okay, so we have 6.022 into 10 to the power 23. Now what would be then mass of one atom? 23 grams contains 6.022 into the power 23. So one atom would contain how much? 23 divided by 6.022 into 10 to the power 23. That will come out to be 3.817 into 10 to the power 23. So this is just simple unitary method. 23 grams contain this many number of atoms. So mass of one atom would be 23 divided by that many number, that is equal to 3.817 into 10 to the power minus 23. Okay, so we have the mass of one atom of sodium as 3.817 into 10 to the power minus 23. Second question, calculate again the mass of the following in terms of 10 molecules of argon. Now argon we know is an inert gas, noble gas. So argon is monoatomic. That means its one molecule is one atom. And gram molecular mass would be its gram atomic mass. And argon has a gram atomic mass of 39.95, or you can take it as 40. Okay, I have calculated it with 39.95. Now when we say, that means 39.95 grams of argon, 39.95 grams of argon would contain 6.022 into 10 to the power 23 atoms. Right? So 10 molecules of argon would contain how much? 39.95 divided by 6.022 into 10 to the power 23 into 10. That would be 6.634 into 10 to the power minus 22. So very easily we can calculate the mass of one atom, 10 molecules, 3 atoms, 14 molecules, etc. in terms of Avogadro's number. Third, how to calculate the mass of one molecule of H2SO4. Now gram molecular mass of H2SO4 is 98 grams. How 98 grams? 2 into 1 plus 32 plus 4 into 16. That will come out to be 98 grams. So you have 98 grams. That means 98 grams is containing 6.02 into 10 to the power 23 molecules. So mass of one molecule would be how much? 98 by 6.022 into 10 to the power 23. That will come out to be 1.629 into 10 to the power minus 22. So these questions are very, very simple. Okay, I'll be giving you a few questions also. We'll see a few questions and then we'll solve, and then we will solve these questions in terms of in your copy. Okay. Another question. Calculate the total number of oxygen atoms present in 0.5 moles of H2SO4. Once again, calculate the total number of oxygen atoms present in 0.5 moles of H2SO4. Simple question, as you have done in class 10 also. How many number of molecules are present in 0.5 moles of H2SO4? Number of molecules present in 1 mole is 6.022 into 10 to the power 23. So in 0.5 moles would be 0.5 into 6.022 into 10 to the power 23. That will come to 3 into 10 to the power 23. That many number of molecules are present in 0.5 moles of H2SO4. Now, one molecule of H2SO4 contains how many oxygen atoms? 4, H2SO4. So, O4. So, it contains 4 atoms of oxygen. So, total number of atoms present in 3 into 10 to the power 23 molecules would be what? 3 into 10 to the power 23 into 4. That is 1.2 into 10 to the power 24 atoms of oxygen. Okay. Very simple again. Then you have another question. Calculate the number of molecules in a drop of water weighing 0.048 grams. Now, a drop of water weighing 0.048 grams. Molecular mass of water is 18. I have taken it as 18.016 because we have 1.008 in terms of hydrogen. So I have taken it that way. You can take it as 1 also, so you will find it as 18. If you calculate it with 18 also, it is correct. No issues. So the gram molecular mass of water is 18.016 in this case. So this many grams would contain how many molecules? 6.022 into 10 to the power 23 molecules. So number of molecules present in 0.048 grams. Very simple unitary method. So you will get the answer as 6.022 into 10 to the power 23 divided by 18 into 0.048. That will come out to be 1.604 into 10 to the power 21. Okay, so that many number of molecules. So generally what we should do is we should write over here molecules, because we have to mention the entities. Then question 4. How many years would it take to spend Avogadro's number of rupees at the rate of 10 lakh rupees per second? Oh goodness. 10 lakh rupees per second you're spending. And you have Avogadro's number of rupees with you. Oh my goodness. Years and years. How many years would it take? Let us say. If 10 lakh is spent, the 10 lakh means what? 10 to the power 6 is spent in 1 second. Then the number of seconds taken to spend 6.02 into 10 to the power 23 would be 6.022 into 10 to the power 23 divided by 10 to the power 6. That is 6.022 into 10 to the power 17. Okay, that means 6.022 into 10 to the power 17 is if the number of, that is the number of seconds taken in spending that much. Now 1 second is how many years? 1 second would be 3.169 into 10 to the power minus 8 years. So this many number of seconds will be how much? 1 second is 3.169 into 10 to the power minus 8. So 6.022 into 10 to the power 17 seconds would be how many years? 3.169 into 10 to the power minus 8 into 6.022 into 10 to the power 17. That would be 1.908 into 10 to the power 10 years. Oh, that many number of years it would take to spend 10 lakh per second. Okay, so simple unitary method questions, you will be very easily be able to answer them. You have solved many of these in class 10. Okay, so you already know exactly, like, you know, about mole concept, and you've already done numericals based on stoichiometry and mole concept in class 10. This would be just a sort of a revision. But anyways, since we require to do all this, since we require to know the mole concept better in the remaining part of the lesson and also in the entire physical chemistry, we are doing this again. I hope you have your class 10 books, and if you have your class 11 books, very good. Go through with that also. Even class 10, revise once in terms of mole concept. I'm giving you a few questions to do in your copy. Do them, and then of course it will be checked later. The first question, I'll dictate it to you. You can write it down. I'll go very slow with the question. You can write it down. First question. Find the molecular mass of glucose. Find the molecular mass of glucose C6H12O6 and calculate the mass of one molecule of it. Once again, find the molecular mass of glucose, formula C6H12O6, and calculate the mass of one molecule of it. Second question. Calculate the number of moles and number of molecules in 4.4 gram of carbon dioxide. Once again, calculate the number of moles and number of molecules in 4.4 gram of carbon dioxide. Also find its volume at STP. Third question. Calculate the number of atoms in each of the following. Calculate the number of atoms in each of the following. First, 52 moles of helium. Second, 52 AMU of helium. Third, 52 grams of helium. Once again, calculate the number of atoms in each of the following. First, 52 moles of helium. Second, 52 AMU of helium. Third, 52 grams of helium. Fourth question. Calculate the number of gold atoms present in 0.450 grams of a gold ring made from 22 karat gold. Once again, calculate the number of gold atoms present in 0.450 gram of gold ring made from 22 karat gold. Given that atomic mass of gold is 197 is the atomic mass of gold, and pure gold is 24 carats. Once again, given that atomic mass of gold is 197 and pure gold is 24 carats. That's the question. Solve and then we'll go into the next part.